Spar 40 amps, XLP EX90 was it? Was it?
Yep.
It's fucking ridiculously long, wasn't it? 48 metres was it?
48 metres, yep.
48 metres long. Clipped to a joist in ceiling. Is that right? Don't need any more information for that? I don't think I do, do I? Spar, 40 amps, XPX90, that's that long, and the method of installation. Okay. So, go to table 1, AS 3008, XLP EX90 equals 90 degrees C cable. 2, go to table 3, AS 3008, for method of installation. I'm recording now. Oh, you are? Okay.
Sell that on YouTube, mate.
So table 3.2, item number 9. Which is on and closed, partially surrounded by thermal insulation. Why is that? Because it's clipped to a joist in the ceiling. WAER tells us that if it's clipped to a joist in the ceiling, we must assume that it's partially surrounded by thermal insulation. Worst case scenario.
May I just ask?
Yeah.
You're writing this out very methodically.
Yes.
But we already know this information, right? Based on the calcs we've already done.
Yeah, we've answered questions on this, and we've looked in there. We had to choose it's in section, I can't remember what it is, section. Yeah,
sorry, I meant more so like going to table 1.
Yeah, we've been through this.
Yeah, it's fine. Let him go.
Yeah, that's all right.
Let him go.
Hey, sorry, I forgot about that.
Okay. So item number 9 takes us to. It would normally, if it was a 75-degree cable, it'd take us to table 10, wouldn't it? Table 11 is a 90-degree cable. Table 12 is a 110-degree cable. So we're going to table 11 because it's a 90-degree cable. Column 15. Table 11, 90 degrees C. Column 15, did I say? Let's have a look how large a cable we need to carry that current of 40 amps. Okay, table 11, column 15 tells us that in order to carry 40 amps, we need a 6mm cable, which will carry 42. Cool. So we've chosen a cable which will carry the current, haven't we? Yeah. Now, how did I do it? How did I do it before? Okay. find a cable which will satisfy VD. What is our VD? That's what I needed, isn't it? Up here, max VD was how many?
3.6.
3.6.
Yeah.
3.6%. 230 times 0.036 equals
8.2.
8.2 volts. So 8.2 volts is our maximum VD for this. Okay, find a cable which will satisfy VD. So we need to work out a VC for our cable using this and this down. It's a long cable, isn't it? Okay. VC equals 1,000 from our formulas here on page 91 of AS 3008. 1,000 times our volt drop, maximum allowable volt drop, 8.2, times 0.866, which is our single phase multiplier, over the length, which is 48, times the current, which is 40, isn't it? 40? Yeah.
It's 40 amps.
Which equals, I'll do it there, gives you a bit more room underneath, which equals
3.73.
3.73.
3.73. Yes.
3.73 millivolts per amp meter. Table 42, because it's a multi-core. Column 8, because it's a 90-degree C cable. Table 42, column 8. Let's have a look. See what we can afford with our virtual currency of $3.73. Table 42, column 8, $3.73. We can't afford a 10mm, it's $4.05. Yeah. So we choose a 16mm. 16mm has VC 2.55. Millivolts per amp meter. Okay, so for current current capacity, we were able to choose a 6mm, weren't we? Yeah.
Yeah.
But it's telling us here, because it's such a long run, yeah, we're going to have to go up several cables, aren't we?
Yeah.
2 cables. A 10 won't do it, but a 16 will. Okay, so now we've chosen a cable for volt drop. We've chosen a cable for current current capacity. We've got to choose the larger cable of the 2 for our final sub-circuit. Be a pig to install on it, but it is what it is.
No.
So now let's work out the actual VD of this cable. Actual VD of cable equals, we'll use this one, not with VD. Length, 48, times current, 40, times our VC, which is this, isn't it? Not this.
Yes.
That's our spirit guide, isn't it? It's done its job now. We can let it float away, can't we? Cross it out, then you don't get fooled into using it. Times 2.55 times, again, our multiplier, 1.155, because this is single phase, isn't it? And that is a 3-phase VC, over 1,000.
5.65.
How many?
5.65.
5.65 volts. Is 5.65 smaller than 8.2? Yes, it is. We'll go that way.
Yeah.
So you've chosen a cable which will satisfy both CCC and VD, and it's a 16mm cable. We've written that down. Got to choose a 16 mil for that one. That's it. Oh, sorry. Coordination.
Yep.
The Bank of New Zealand. IB. Less than or equal to IN, which is less than or equal to IZ. Bank of New Zealand. This is your maximum demand or design current.
Yep.
Max dem or design I. This is your breaker size. And this is your CCC
Of cable.
of the cable. So our maximum demand of this, or actually our design current, it's not maximum demand, is it? Because it's a final sub-circuit, is 40 amps. The current carrying capacity of the cable, what is that? We didn't work that out, did we? Let's have a look. It's a 16 mil cable, isn't it? Where do we go to find that? Table 11, column 15. And it is what?
78 amps.
78 amps. 78. Breaker size. Go to table 8.1 for a list of breaker sizes. And we could choose a 40, couldn't we?
Yes.
That'd be less than or equal to that, wouldn't it?
Yeah.
And that's less than or equal to that. Or a 50.
Yep.
What's the next one? 62? 63?
63. That's it.
And the next one was an 80, wasn't it? So we can't use the 80.
Yeah.
We could choose either one of those breakers. Yeah?
Yeah.
But I'd select that one because it's safer, it's going to trip quicker, isn't it? And that's what we want. Done deal.
Happy days.